This video will use our first notes page for Standard 9. This is in class 36, and we will be talking about properties of a shape called a rhombus today. So first and foremost, we're going to talk about what the definition of a rhombus is, and then there'll be a series of other pieces of information that we'll also learn are true for any shape that qualifies as a rhombus. There'll be a couple new vocabulary words and then several examples to make sure that you can put the properties into use. So first and foremost, a rhombus is a parallelogram. So we're going to focus in on the same type of information that we've used in Standard 8. Sorry about that, my pen is dead. So a parallelogram that has additional information true. So the additional information is about a pair of consecutive, congruent sides. Now that's a new thing that we haven't dealt with in our other parallelograms. It used to just be that opposite sides were congruent. So we're starting with that same parallelogram shape, but we're adding an additional feature that then qualifies that quadrilateral to be a rhombus instead of just a parallelogram. So a rhombus is our first example of what we'll call a special parallelogram. That's the focus of Standard 9. So what that means is if a rhombus is a parallelogram, all of the things that we learned about parallelograms are still true. So that was back in our Standard 8 notes in class 33 is where all of those parallelogram properties are listed. But as a quick recap, opposite sides will be parallel, opposite sides will be congruent, opposite angles will be congruent, consecutive angles are supplementary, and the diagonals bisect each other. In addition to that, when we add in a pair of consecutive congruent sides, what actually ends up happening is that all four sides in the shape end up being congruent to each other. And the reason for that, if we make a quick little sketch here of a rhombus, we have to draw it like a parallelogram, but we need these two sides to match. So in order to keep this parallel and to keep the parallelogram consistent, we know opposite sides are going to have to match as well. So we end up having four sides that all end up being congruent to one another. The other two things that happen are related to the diagonals of the shape. So the first thing is that diagonals will be perpendicular to each other. That may be a new word for you. So we're going to talk about what perpendicular means down below. Okay. And then the second thing that's true about the diagonals is that they bisect not only each other, because that's a parallelogram fact, but they also bisect opposite angles. And so we'll talk about what that looks like down below as well with a picture. All right, so some vocabulary. Perpendicular. Perpendicular describes that objects intersect each other in a very specific way. And that very specific way always forms right angles. So when we talk about the diagonals being perpendicular, that would look like segment LN and segment KM. Anywhere those diagonals intersect each other is always going to be exactly 90 degrees because all four of those angles are right angles. The word perpendicular is pretty lengthy. It's got a lot of letters. So there is a symbol for perpendicular. It looks like an upside down T. You can see that there's two little back-to-back right angles in that symbol to remind you what perpendicular stands for. That fourth property brings back another vocabulary word that has a couple different meanings now. So we're going to talk about the idea of bisect in the context of a rhombus. So if we reread that statement, it says that the diagonals bisect the opposite angles. So what we know about bisect is in general is that it describes dividing an object into two congruent or equal parts. And so this time around, when they tell us it's bisecting opposite angles, we're back to the way that we've used bisector at the beginning of the year. This angle N is divided up into two congruent parts, and this angle L is divided up into two congruent parts. But you'll notice I used the same arc for all four of those, And that's because combined with a parallelogram fact about how opposite angles are congruent themselves, we actually end up with information that all 4 of these little angles end up being congruent when we're dealing with a rhombus. The same thing would be true the other way. So if we focus on KM as a diagonal, all 4 of these little angles will be congruent as well, thanks to a combination of the parallelogram fact that full opposite angles are congruent, and now our new rhombus fact that these angles are also bisected, divided in half. All right, those are all of the properties of the rhombus. So now it's just about diving into these examples, seeing which one of those properties apply, and then figuring out a way to solve the problem using that particular information. So just so that we're aware, all of these shapes that we're looking at are going to be rhombuses now for today's notes. So when we're trying to solve, we want to keep in mind that we know more than we knew when we were in parallelogram mode. Kicking us off is a piece of angle information. So the measure of angle LKM, that's this portion, is 52 degrees. And they're asking us to track down the measure of angle LKN. LKN is that whole angle. So we're going to use that 4th property that we just discussed, where we showed that these 2 angles matched. That 52 can hop right across that diagonal and fill in that angle right next door. And then we're going to go all the way back to standard 2 and a little angle addition postulate. If I want the measure of angle LKN, I can take the 2 parts of that angle and I can add them together. Another option would have been that when an angle is bisected, the whole angle is equal to 2 of the smaller angles. Both of those approaches will give us the same measurement for angle LKN. It should turn out to be 104 degrees. All right, example 2, let's see what's in store for us here. The measure of angle MON. MON is right there. And rather than put my 8x plus 2 on the picture in that spot, I'm going to think back to what we put up here. Remember, the diagonals in these shapes are perpendicular. So we already know that that angle, as well as all the others, is 90 degrees. That's based on our 3rd reason up above. Diagonals are perpendicular to each other. So what we can do, since we already know the measure of that angle is 90, is we can take 90 and set it equal to what they're telling us is true about the angle in terms of x, and then that gives us a little equation that we can solve to help us track down the actual value of x, since that's what they requested in the beginning of that problem. And to be perfectly honest, remembering that these central angles here are all 90 degrees is one of the trickiest things for geometry students. So sometimes as soon as I read that there's a rhombus, I will go ahead and I will fill in all of these middle angles with 90s, just because usually that can help us to track things down. Or if we get stuck, that might be the answer to getting us moving forward in the problem again. All right, moving on to question number 3. This looks different because we only have 2 letters here. So that means I'm not dealing with angles anymore. I'm either dealing with sides or diagonals. So if I investigate LK, that's over here on the left side of the shape. So that side is going to be 3 times x minus 12. And then LM is the top of the shape. That's going to be x minus 6. Now, if this was a parallelogram, we would be in trouble because there's nothing that's true about consecutive sides. But we are not in parallelogram mode. We are in rhombus mode. So remember, reason number 2 up above says that all 4 sides are congruent. So we can take any of the 4, no matter where they're located, and we can set them equal to each other to enable us to solve for x. Using your distributive property, this side will become 3x minus 36 when you have that all multiplied out. I'm going to go ahead and subtract x from both sides. so that those are all collected together on the left. Make sure you're careful when you do that because that leaves a -6 on this side. Add 36 over. -6 plus 36 is +30. And then last but not least, divide by 2 to track down x equal to 15. Make sure you're always checking that you've completely answered the question. This question also asks us to find mn, which might not seem possible to you, but remember I marked all 4 of these congruent. So we can find mn either by using LK or LM. I think LM looks a little bit simpler, so I'm going to use that expression. So mn is really equal to this 15 that I figured out x was equal to, but then -6. Final answer of mn equals 9 to take care of the second half of that problem. All right, go ahead and flip that page over and we'll be back for a few more examples. Picking back up on the back side, it looks like we have 2 more rhombus problems to take care of. I know that they're still rhombus problems because I see that shape name in the instructions. These look a little bit different though because it looks like I'm tracking down several different angles for both of them. And honestly, when they are asking me to find a whole bunch of angles, I often find it to be much easier to just fill in my shape and then to go from there. So for one of these, I'll show you that approach, and for the other, I'll try to just directly find the angles that they're listing in order, and you can kind of feel out which one you feel like is better. Now, I'm going to take my own advice from earlier. I read the word rhombus, so I'm headed straight to where those diagonals intersect, and because this is an angle problem, I'm going to fill 90 degrees in all 4 of those spots. That's a little bit awkward because I wrote over the top of letter E, so later when we're thinking about these angles, we'll have to remember that that was an E there in the middle. But I think that's going to pay off in the long run. All right, one more piece of information to get onto my picture. The measure of angle ABE, so starting at A, traveling to B, ending at E, means that that 14 should get slid into that little corner right there. All right. Now I'm going to do this problem as if I did not have a list. I'm just filling in anything that I can in this picture. So my attention is immediately drawn to this triangle. If I closed up that angle that I highlighted and I made it into a triangle, I have 2 of the 3 angles inside that triangle already labeled. Hopefully you remember back from standard 3 that triangles always add up to be 180 degrees. So we can take 180 minus 90 minus 14, and that should help us fill in this last angle in that triangle. So if we do that, it's looking like 76 degrees is going to fill in that corner. Now there's all kinds of symmetry inside the rhombus shape, but there's also a whole bunch of details related to parallelogram properties and the new properties that we talked about on the other side of the page. One of them that's coming to mind right now that it's new is that this diagonal is bisecting this angle. So if this part of the angle is 14, the part directly beneath it is also 14. Same thing here. If this part of the angle is 76, the one right next to it is also 76. So you can start to see some of that symmetry I was talking about. If I'm looking at this diagonal, everything is matching up on those 2 sides. If I look at this diagonal, everything is matching up along those sides. I've got more opportunities now to use triangles, but that problem is going to match this one perfectly. 180 minus 90 minus 14. So those 76s that I filled in at the top are also going to land on the bottom. Remember, opposite angles are congruent, or alternate interior angles are congruent. And then the same thing is going to happen on this far left. Those are both going to be filled in with 14s to match the ones that are opposite or alternate interior on the other side. All right, so that's what I mean about filling in all of the angles. Once you have 2 angles, the 90s and whatever they're giving you, it's usually relatively simple to just fill in the rest. And now we just have to track down the ones that matter to us. So if we're going from C to D to B, from C to D to B. That traces out the bottom half of this angle at D, so that's 14 degrees. This one uses the same letters, but in a different order. So from D to C to B is that whole angle at the bottom. So we need to put those two 76s together to cover that whole angle using a little angle addition postulate. That's going to be 152 degrees. Next up is angle AEB. Remember, E is in the middle. So AEB is that angle that I started with at the beginning, 90 degrees, thanks to those diagonals being perpendicular. And then last but not least, angle BAC. BAC is this one right here. That was the first one that I solved for when I was using my triangle sum, 76 degrees. All right, let's take a look at number 5. And I'll try to do this one instead of filling everything in at the beginning. I'll try to just go in order and kind of show you what that strategy would look like. First things first, the measure of angle DAB is 124. I'm noticing that DAB is that entire angle. So it is possible for me to draw an arc in there and label the whole thing as 124. But if we're in rhombus mode, like we are, the best thing to do is actually to divide that in half, because remember this diagonal, this one here, is going to bisect that angle. So that 124 is going to get split evenly, half and half, between these two sides of that angle, 62 degrees for both. Okay, so now that that piece of information is on the picture, instead of finding everything like I did in example 4, I'm going to try to work in order and see what we can come up with. Angle ACB is up first. So angle ACB is right here. I'm noticing that that's the same diagonal I used up here. So because this is a parallelogram, these opposite sides are parallel. That angle is an alternate interior angle with that one of those 62s I just labeled. So it will also be 62. Continuing on, CED as an angle is up next. So from C to E to D is right here in the middle. That, because of my diagonals being perpendicular, is going to be 90 degrees. Next up, the measure of angle ABC. ABC is going to be this entire corner out here. So I'm going to think back to a parallelogram property. This whole entire angle, remember, was 124. That whole angle and this whole angle are consecutive interior angles, and so that means they need to add up to be 180 degrees. So if I take 180 minus that whole angle up there with A as a vertex, that's going to tell me what this whole angle over here with B as a vertex is equal to. That's going to turn out to be 56 degrees total. If you want to label that in the picture, my suggestion would be the same as what we started with. 56 degrees gets split in half. So there'd be 28 degrees here and 28 degrees there. Last but not least, I'm looking for the measure of angle ADE. ADE is a portion of this angle over there. We know that this angle is bisected, but it's also congruent to this opposite angle. So that means that these 28s can move over here. And so that last angle I'm looking for, the measure of angle ADE, is going to be 28 degrees. So 2 different approaches. You decide which one you like best. I, in particular, am a fan of filling in the angles and then answering the questions. But either way, as you can see, will let us fill everything in and get an answer. All right, these last 2 problems are review problems. So make sure you've noticed in the instructions we're not dealing with rhombus problems anymore. We're dealing with a parallelogram in these. So we're only allowed to use our parallelogram facts. So if we're looking at x and y, This is not a place where the diagonal is bisecting the angle, so we can't pull that 18 up and fill it in. But we do know that opposite angles are congruent, so we could say that y is equal to 50. And we do know that alternate interior angles are congruent, so we could move that 18 if we wanted. And then we always have the ability to use triangles, so it looks to me like y and 18 and x all live in a triangle together. So perhaps adding them up and setting them equal to 180 would be a good option to help us track down that x is equal to 112 degrees. Moving on to the last one, looks like number 7, they're giving me information about the sides. Unlike in a rhombus, I can't mark all 4 sides congruent. I have to stick with opposite sides only. As I marked, I noticed both the left and the right use x, but the top and the bottom do not. So I'm going to start with the left being congruent or equal to the right. Subtract x to get all of those collected together on the left. Add 5 and divide by 2. So x turns out to be 15. And then if I want to find y, I think the best way to do that is to plug the x in. So 4 times 15 will tell me that that side is 60. And if the top of that parallelogram is 60, then the bottom must also be 60. My 2y minus 12 then can be equal to 60. Add 12 to both sides and divide by 2. And y turns out to be 36. All right, that's it for in-class 36. I'll see you back in class. Thanks for learning about the rhombus today.